And so we will now begin with our third class. So welcome back everybody to Global Kids Connect Mathematics. Last class we left off for after doing linear equations. And for today's class, we will now be focusing on inequalities. So we will jump right in. Great, then we will begin with inequalities. So our first concept for today is linear inequalities. So similar to linear equations we learned last class. However, this time instead of having equal signs, we will have inequalities. So what are linear inequalities? The definition is a mathematical statement where two expressions are compared using these symbols. So we'll take a look at each one. The first one here represents less than. So 1 being less than 2. The second symbol represents the opposite, greater than. So we use when 2 is greater than 1. Our third symbol is uh, less than or equal to. And so we use this for situations both when two numbers are different, when one is less than 2, or we can also use them when two numbers are also equal, because this bar below represents the equal sign. And so uh, an important thing to remember is uh, the side that has a point, represents the smaller side. And then if it also has a bar below, that it represents it is also equal to. Uh, Taking a look at the last one, we have the same thing, but the opposite direction. We have greater than or equal to. So we use this same situation when one number is greater than the other, or when two numbers are equal. Fairly simple. And so these kind of symbols can be utilized within algebraic equations as well, as you can see within this example, where 2x minus 7 is greater than 8. We'll go into detail about what this function means in a example question later on. But then first of all, some key skills to remember is to solve by isolating the variable, considering the inequality sign direction, and flipping the sign if multiplying or dividing by a negative number. So we'll take a look at a couple cases where this happens. So we'll take a look at our first example question. So our problem states, which of the following is not a solution to the inequality 2x minus 7 is greater than 8? So we have to find, first of all, a answer choice that is not a solution to this inequality. So how do we find that? So you can think of when you're given a inequality equation, think of it as the same as just a normal linear equation in which you can move around the numbers, move around the variables. And so if we keep the x variable on the left side as it is, we will have 2x. Keep the inequality sign as it is, but we will move the negative 7 to the right so that we get a plus 7, excuse me, so that we get 2x is greater than 15, or x is greater than 7.5. Uh, and so from here, we can see that we re-expressed our initial inequality equation from this to this, so that we isolated the x variable. Knowing this, every value of x must be greater than 7.5 in order for this inequality to be true. And so we'll take a look at the answer choices. Uh, from here, we can see that I think this was an error within the correct within the question. Yes, like you said, Muhammad, yes, that is true. Only D is the correct choice. I think we were supposed to say a solution to the inequality, not a solution. Excuse me for that. But then, yeah, if we, for example, we get rid of the not, then the only answer choice that is a solution will be D, which is 12. So any questions for this one before we move on? If not, then we will move on to our next question. Yeah. And so we have another practice question for linear inequalities. Our second question asks that given the inequality 2x minus 6 is greater than 13 plus 7x, which of the following is an invalid value for x? So we'll do the same thing like we did for our previous question. However, now we have both sides to worry about. Uh, we have, I'll rewrite the equation again. We'll move the x variables to the left side and then all the constants to the right side. So if we do that, we'll move this 7x to the left and this negative 6 to the right. If we do that, we get 2 minus 7, which is negative 5x, is greater than. If we move the negative 6, we get 13 plus 6, or 19. And therefore, here we have to divide each side by negative 5. If we do this, we get x is smaller than. Because we divided, so multiplication or division by negative values will result in the inequality having flipped in the signs. And so instead of having greater than, we'll have less than. And then because we divided 19 by negative 5, we get negative 19 over 5, which is equal to
You do
3.
3.8.
Yes, negative 3.8. That is correct. So if we have this here, right, we can see that from the answer choices. We'll take a look at each one individually. If we say x is negative 5, then it does make sense because negative 5 is smaller than negative 3.8. If we take a look at answer choice B, negative 4.5, also the same case, it is smaller than negative 3.8. For negative 4, it is still smaller than negative 3.8. And so the only value for x that is invalid can be answer choice D of negative 3, because negative 3 is bigger than negative 3.8. So any questions for this one?
So only when multiplying or dividing the other sides of this equation can we change the symbol of this equation, sir?
Yes, that is true. And so let's take a look again. So we managed to re-express the equation into this format. And then from here, we need to isolate the x variable on its own. And so because it has a coefficient of negative 5 in front, we have to divide each side by a negative 5. And like we said within our concept, when we are either multiplying or dividing by a negative value, we have to flip the inequality sign. So this is a very important thing to memorize and remember. And so whether it be any constant, any value, if it is negative and you have to either multiply or divide, make sure to always flip the inequality. And so when we have a greater than, like here, if we flip it, we get a less than. Uh, but for example, if we had a greater than or equal to, and then we did the same thing, either divide or multiply by a negative number, we then get smaller than or equal to, smaller than and equal to. So make sure to remember these relationships when flipping. And then, yeah, that will be all. And then another key thing to remember is uh, sometimes you get a, let's say instead of having the variable on the left side, you first did the variable on the right side. Then you would have gotten uh, 5x, this, and then negative 19. But then let's say, for example, you wanted to have the x coefficient on the left side. In that case, then what you can do is you can either move around each part to get this expression, or you can also just flip the entire expression itself so that we can get 5x is smaller than negative 19. And this will also result in the same answer. So there are multiple ways to do it. Just choose whatever is comfortable for you. Yeah. Any questions for this? If not, then we can move on. And so the solution is the same as I had explained. For tips is to simplify step by step and to test each value. So make sure to take my tip will be to write down each step within your scratch paper so that you don't make any mistakes regarding the signs, the values, or anything like that. And so moving on to our second concept for inequalities is systems of inequalities. So you'll be kind of familiar with systems of something because we covered it a lot within our past classes. And so it's basically the same thing. So a set of two or more inequalities with the same variables. And so, for example, we here have a inequality with the variable x and another inequality also with the variable x. So if you're given two of these equations, these will be classified as a system of inequalities. And so a couple key skills for such for problems regarding this concept is to find the overlapping region by graphing or solving each inequality and identifying common solutions. So we'll take a look at what these could mean with our practice questions. And so our first question asks, which of the following cannot be a valid value for x for the system of inequalities of these two inequalities? So we have to find a value of x within the answer choice that satisfies both sides of the equations. So there are multiple ways actually to solve these kind of questions. You could either plug in each answer choice within the to each equation and to test whether both are true. However, for our case, we will take a much more algebraic and uh, mathematic approach regarding it. And so if we have our first inequality, then I'll write it as an equation. Equation one, 2x plus 2x is less than 48. We can add the x variables together so that we get 4x is less than 48. And then we can divide each side by 4 so that we get x is smaller than 12. So we managed to simplify our inequality. So this will be our first expression. We can simplify the second inequality as well. So we have this equation. We'll keep the x on the left side, move all the constants to the right so that we get negative 3 on the right side. And then here we will multiply negative 2 to each side in order to get rid of the negative 0.5 on the left side. And so if we do that, if we multiply each side by negative 2, we then get x. Because we multiplied by a negative value, we flip the sign of the inequality so that we get a greater than and 6. And so this is our second inequality. And so when we have two inequalities, we can combine them to get a combined expression. So we can say that because x for our second inequality says it has to be bigger than 6, we'll just write that it's bigger than 6. And then our first inequality stated that x must be smaller than 12 as well. And so we also put a less than 12 on the right side. If we have it like this, then we can much more easily find a x value that satisfies both inequalities. And therefore, we'll take a look at the answer choices. We can see that uh, 11 is fits within 6 and 12. We can see that 9.5 also fits between 6 and 12, as well as 7 fits also between 6 and 12. And therefore, the only choice that cannot be a valid value for x will be A of 5.5. Yeah. And so because 5.5 is less than 6.6, it will be here. Uh, Answer choice A is the only value that is cannot be a x value. Yeah, no worries. Yes, that is true. Right. A. Any questions for this question? Okay, if not, then we can move on. And so solution was the same as I explained. And then a tip for this kind of question is to identify the range where both conditions hold. So like I showed you, we can combine two inequalities to get a combined expression, which talks about which identifies the range of both inequalities. Okay, we can move on. So we have another practice question. So if B is the solution to the system of inequalities of these two inequalities, which of the following statements must be true? So a slightly different, we have to look at the statements here, and then choose the ones that must be true, that are always true. So we'll solve it step by step. And so, like we did for our previous question, we will simplify the inequalities independently. So for our first one, we can say that like I did for our previous question, we can move the b variable to the left side so that we get 0.75 minus 1 equals negative 0.25b is greater than negative 6. From here, we can multiply each side by negative 4 or divide each side by negative 0.25. Both are correct. If we do that, we have b on the left side. We flip the sign of the inequality, and then we get a 24 on the right. So this is our first expression. For our second inequality, we can simplify as such. Same thing as we did before. Move everything to each side so that we get this. And divide each side by a negative 3. Flip the sign, and then we get a 4. So this is our second inequality. We can now, like we did for our previous question, we can uh, combine these two inequalities so as to get b is greater than 4 and less than 24. And so we will now uh, look at the answer choices. So we can see that for statement 1, it says b is less than 24. And so, see, true. So important things for statement questions is that uh, as long as there are parts within the statement that fit within these our inequality, it will be true. And so when the first statement says that b is less than 24, we can say that it is true because we can see that here that b is less than 24. And so it is a true statement. And then for statement 2, when if b is greater than 7 and less than 26, this is also true because the values of b that will be within this general inequality will also fit within to this inequality as well. And so what I mean by that is if b, let's say the smallest integer that b can be is 5, right? And the largest integer it can be is also 23. And we can see that both values fit within to this the second inequality. And therefore we can say that statement 2 is also always true. However, for statement 3, when b is less than negative 24, we can say that this is incorrect because from our general inequality here, we can see that b cannot be a negative value. It is always positive. And therefore, we can state that statement 3 is incorrect. And therefore, our only correct choices will be statement 1 and statement 2. Does anybody have any questions for this one?
Um, I I do have a question.
Yes.
The second option,
Mm-hmm.
it says B is less than 26.
Yes.
And okay, so how does that like correlate with the B is less than 24?
Okay. So I'll explain more into detail about that. So we found our general inequality here. So we know that because these two came from inequalities one and two, this general inequality must always be true. So this is always true. And so knowing that this statement is always true, we can look at the statements given in the problem one, two, and three. For the case of statement two, it says that the inequality is b is greater than 7 and less than 26. So your question was you're kind of confused on the less than 26 part. And so how you should kind of understand statement problems is that uh, if because it's the same variable, any values that can fit within this general inequality must also fit within the statement inequalities as well. And so for our case, we can see that uh, huh, one moment.
So here in the less than sign you told 4 is less than B which is greater than 24. But in the second option they told 7 is less than B which is greater than 26. But if the answer for the B must or sometimes maybe it's 5, let's think like that. If it's 5 then it
Mhm.
does not fit into the second option. And in the question they ask must be true. So it's really only option 1, right, sir?
Ah, okay, I see. Thank you so much for that catch. I I do believe what you said is correct. Apologies. Uh, yeah, so I think I glossed over that part. And so for statement two, like I expressed, any values within the general inequality must also fit within the statements. However, because the second statement states that 7 is greater than 5, however, we also have values such as 5 and 6 within the general inequality, and therefore we cannot say that statement 2 is always correct. And so the important thing regarding statement two then will be that although every value is less than 26, because every value was less than 24, we cannot say that every value is greater than 7, because we also have values that are less than 7 within our always true general inequality. Thank you for pointing that out. And so our final answer will be statement one only. Does anybody have more questions regarding this one?
No, sir, not at all.
Okay, then we can move on now. Yep, we'll move on to the next concept. And so our last concept, as I know, is linear inequalities in the XY plane. And so the definition for this is that inequality is represented by a linear equation in the XY plane where the solution is a region on one side of the line. And so we'll take a look at what this could mean with a example question. But first of all, key skills is to graph the boundary line. Uh, so this will be very important, boundary lines. So they are solid for inequalities that include equal to, and are dashed for inequalities that do not include equals. And then we will shade the appropriate region based on the inequality sign and then test the point to confirm. So it'll be easier to understand when we take a look at a example question. And so our first example question is, which of the following inequalities correctly represent the shaded area on the XY plane below? So, like we talked about within our concept, we can see that first of all, the first thing that comes out to us is that there is a dashed line for our linear line. for our linear equation. So because we have dashed lines like here, we can say that it will probably not include equal to signs. So it will be either greater than or less than. And so automatically we can get rid of answer choices B and D because they include equal signs. And so it's between A and C. And therefore, and then we can see that uh, we say the equation is like y equals ax plus b, just generally, and that represents this line here. We can see that the shaded area is below that line, right? And therefore, and we can say that the y values for the line ax plus b are always less than, because we can see that the maximum value that the y value can be for this line is on uh, the actual line itself. And then we have shaded the area that is below, which means that any y value that is less than the maximum y value, which is the line itself, will be true solutions. And therefore, that's why we say y is less than our linear equation. Before we move on, anybody have questions regarding this? Okay.
Okay, I do have a question.
Yes, yes.
How, okay, so if dashed or dotted lines represent just less than or greater than, then what kind of lines represent greater than and equals to or less than and equals to?
Okay. And so, like I explained within our concept, a solid line, so which means if we have less than or greater than is a dashed line within our XY. For like you asked, greater than equal or less than equal, we'll have a line that is continuous, like a just a normal linear equation line that we are familiar with.
Oh, okay, thanks.
Yeah, no worries. And so now that we got out of the way, we can move on with our question. So because now we know it will be less than, which corresponds with our answer choices, both having less than inequalities, we can now try to find the linear equation itself. And so, like we did for linear equations for our previous class, we can find the slope by saying, let's say the variable for the slope was a for our case, uh, the change in y over the change in x. For this, let's say that the y1 was 3 and y2 was 4, was 0, excuse me. Then we will get y2 being 0, y1 being -3. And then if we have x2, which is the later value of 4, and then x1, the initial value of 0, if we had the origin as our basis, then we can say that x2 will be 4, while x1 will be 0. And then simplifying this, we have -3 over 4 for our slope. And then our last part for finding the y-intercept, which is b in our case, uh, just take a look at the graph itself, find where the linear line, crosses the y-axis here. We can see that it crosses at a point of y value of 3. And therefore, we can say that b is equal to 3. And therefore, we can rewrite our inequality as y is less than our slope of -3 over 4x plus b, which is y-intercept of 3. And therefore, we can take a look at our answer choices, and we will see that answer choice A is the correct choice. And so does anybody have any questions regarding this one? Okay, if not, then we can move on. Great. One moment. Okay. So solution is the same. And then tip is to use the slope intercept form to identify the line and check the shading direction like we did for our solution. Our second practice question is, which of the following inequalities represents the shaded region above the line y equals 2x minus 4 on the xy plane. So this is a slightly different question as we are asked to kind of graph the equation ourselves instead of being given the graph itself. And so we can easily do that by first we will draw the xy plane as it is. So we have x here, y on top. And then before anything, we can draw the line y equals 2x minus 4. And so first thing you should do is always find the y-intercept point and draw it. So for our equation, we can see that the y-intercept is negative 4. Therefore, let's say if our negative 4 was here, then it will always pass this point. And then because our slope is a 2, it will be a kind of steeper slope. So let's say it is positive, the slope, and therefore it will be pointing upwards. And then it doesn't have to be exact, but we just have to get a grasp of what it will be like. And then the question asks for which of the following inequality represents the shaded region above the line. And therefore, if we have a line here, then the question asks for the region where it is here. And so you can see uh, when the question asks for regions that are above, you can see that includes y values that are greater than the maximum y values of the line itself. And therefore, similar to the previous question, within context, we can say that y in terms of the linear equation, when the shaded region is above, it will be greater than the linear equation. And so we know that it will be greater than, but then some of you might be confused regarding whether it's greater than or greater than equal to. So in cases of context questions like this one, where it talks about region that is above the line, uh, when a region is above the line, it usually means that it does not contain the line itself. And so it will be a greater than instead of a greater than equal to. Uh, if the answer was to be greater than or equal to, the question itself would state, for example, which of the following inequalities represents the shaded region that is above and also including the line? And so when the question deliberately explains to you that the shaded region also includes the line, then it will be a inequality that has a equal sign. However, if the question only states that the shaded region is above the line, then it is a inequality that does not include the equal sign. And therefore, we can say that our final answer, being this inequality, we'll check the multiple choice, and we can see that answer choice A is correct. Does anybody have any questions regarding this one?
No, sir.
No? Okay. Then I think we can move on. So we will have our challenge question, first one for today. A basket of fruits can hold up to 33 items. Jan can only buy oranges as a pair and apples as a pack of 6. How many pairs of oranges can Jan buy at maximum if his basket is already filled with 4 packs of apples? So from here, we can analyze the information given to us step by step. So Jan's basket of fruits can hold up to 33 items, and therefore uh, the amount of items, the maximum is a 33. Let's say number of items. And then Jan can only buy oranges as a pair and apples as a pack of 6. So she can only buy 2 oranges at a time or 6 apples at a time. Next up, we say that how many pairs of oranges can Jen buy at maximum if his basket is filled with 4 packs of apples. And so we have to find the number of pairs that Jan can buy more when she already has 4 packs of apples. So if she has 4 packs of apples, because each pack of apples is 6, we can say that the total number of apples Jan has is 4 times 6, which is 24 apples. And so if there's already 24 apples within the basket, we can say that there's 24 apples plus if we say for example, the number of orange pears we set as the variable x. You can set it as any variable you want. Then we can say the number of oranges itself will be 2x because each pair of oranges are 2. And therefore, this expression is the number of items or number of fruits for our context. And then we saw that the total number of fruits that Jan's basket can hold is 33. And therefore, we have 33. I'll write it up. 33 is the maximum. This includes 33 because it says holds up to, and therefore our inequality will be a less than and equal to. And so we can now solve this inequality that we created to find the value of x. For that, we can leave the x variable on the left side and then move everything to the right side so as to get 9. Because 33 minus 24 will equal to 9. And then divide each side by 2 so that x is less than
4.5.
4.5. Yes, that is correct. And then you might be tempted to write down 4.5 as your final answer. However, that is not the case. That is because uh, looking back at what we set as our x variable, we set it as the number of orange pears. However, pairs can only be integer numbers. So either 1, 2, 3, 4, or 5 pairs. We cannot buy 0.5 pairs of oranges. Uh, Although mathematically you could say if you buy 1 orange, that is 0.5 pairs. However, for the context of the question, very important, in the context of the question, it says Jan can only buy oranges as a pair. So this means she can only buy 2 oranges at a time. She cannot buy one, she cannot buy half an orange or anything like that. And therefore, we have to find the x value that is a integer while also being the maximum value it can be, because our question asks for the maximum number of pairs of oranges. If we know that, then we can say that x, the largest x can be, will be 4. And therefore, our final answer will be x equals 4, or 4 pairs of oranges. Anybody have any questions for this one?
Also,
Everyone else also good? Okay, then I think we can move on. So our solution is the same as I just explained. Then a tip for this kind of question is to translate word problems into inequalities and consider constraints. So like we did for this question, always read the question carefully because every detail and every information given to you within the context questions are very crucial and very important in solving it. And so always translate word problems into inequalities or into any mathematical expression when possible. And also consider constraints. So this means any rules within that are stated within the question, such as Jam being able to only buy oranges as a pair and apples as a pack of 6. So make sure to keep those in mind when solving such questions. We'll now move on to our final challenge question of today. So our problem asks, oh, we see that the solution actually kind of gives us the answer, but then that'll be fine. Which of the following inequalities does not contain solutions in the third quadrant of the xy plane? And so try your best not to look at the solution for now. Don't try to cheat. I'll go through everything that is stated within the solution. Uh, so we can see that the question asked gives us four inequalities, A, B, C, and D. And then we can see that which of the following inequalities does not contain solutions in the third quadrant. So first of all, what is a third quadrant? So when we know a XY plane, we graph it a lot for a lot of our graphical questions. We can divide each, I guess, space, each square as its own quadrant. So this space here will be our first quadrant. And then we will move in the counterclockwise direction to get this side being the second quadrant, and then below being third quadrant, and then the last one being the fourth quadrant. And therefore, our question asked does not contain solutions in the third quadrant. So because each linear equation is expressed as a inequality, we can kind of understand it as which of these shaded areas do not contain the third quadrant. And so we can try to solve it uh, like here. So for these kind of questions, there's no real, I guess, cheat or hack to solve it quickly. You just have to go through each answer choice individually until you find the answer that satisfies the conditions stated by the problem. And then first of all, we'll take a look at answer choice A. So we have the linear equation, 2x plus 10. So first of all, the y-intercept will be 10. And then because it's a positive slope, it will be like this. And then our inequality for answer choice A is greater than. And therefore, like we covered within our practice questions before, greater than is equal to the shaded area that is above. Then if we shade it, like here, we can see that there is an area that gets shaded that is within the third quadrant. And therefore, we can say that answer choice A cannot be a correct choice. And so we now move on to answer choice B. Here, first, again, we set the y-intercept. Here it was -2, and then our slope here is negative, and therefore it will slope downwards. And therefore, we'll roughly have a graph that is like this. And then lastly, we have our inequality that is less than. If it is less than, then it will be below the line. And therefore, if we just shade it like this, we can see that there is an area that gets shaded within the third quadrant. And so answer choice B is also incorrect. And so let's try out answer choice C now. We have x, y. Again, y-intercept is 8. And we have another negative slope. So let's say it looks like this, for example. And then most importantly, our inequality is greater than. And so if we try shading the area that is above because it is greater than, we can actually see that there is no area that is shaded within the third quadrant. It's empty. And therefore, we can state that answer choice C is an inequality that does not contain solutions in the third quadrant, like the problem asked for. And therefore, our answer will be C. We can take a look at answer choice D as well. We take a look at it. We can say that this y here, the y-intercept was 7, and then we have a positive slope, so it will slope upwards, excuse me, like this. And then it is less than our inequality. And so we shade the area that is below the line. If we do this, we see that there is an area that gets shaded within the third quadrant, and therefore we can say that answer choice D is also incorrect. And therefore, there's only one choice that is correct, which was answer choice C. And so, does anybody have any questions regarding this one?
No, sir.
No.
Okay. Uh, That's great. So it seems that everybody managed to understand all of our concepts for inequalities. And so things we have a bit more time left. We'll just go through the concepts one more time just to get used to them. So going back to our first concept, linear inequalities, very simple. Just memorize what each sign will mean. And then, like we did before, practice isolating variables for that is, and then this tip goes for every other concept that we did until now for algebra and linear equations. Isolating the variable is always uh, most of the time required within questions. So it's great if you can get used to them. And then considering the inequality sign direction. And so don't get confused. Make sure to clearly read and understand which which side the inequalities are in. And then lastly, flip the sign if multiplying or dividing by a negative number. So we covered this a couple of times within our practice questions, but then very key thing to memorize because if you forget to flip the signs and you divide it by a negative number, then your answer choice will be totally different. So I would say that inequalities and any questions regarding inequalities are easy to make mistakes on if you forget a couple of key steps and key rules regarding it. Uh, and so make sure to memorize each step very clearly. Our second concept that we learned for today was systems of inequalities. Similar to systems of equations, systems of linear equations like we did before, just make sure to you understand how to combine two inequalities like here. So we had one equality here, another inequality here. We can combine these two so as to get our third one here. And then, oh, yeah, and so you can find the overlapping region, and then you can either graph or just solve algebraically for the questions. And then the last concept we covered for today was linear inequalities in the XY plane. So for this one is all about graphing and understanding which area you have to shade and is shaded. And so key things to memorize if you're given, let's say, an equation such as this, where it is equal to y is equal to x plus 2. For cases where y is less than the the linear line, then less than inequalities or less than equal to inequalities always are the shaded area that are below. And then another key thing to memorize is that if the inequality is not equal to, but only less than, then the line itself should be graphed in a way that is dotted, like here. And so the shaded area will be below this. So these are a couple key things to memorize. And then the same thing goes for the other way around. If y is greater than x plus 2, then instead of being below, the shaded area will be up here above. And so I hope everybody kind of understand it, the key concepts for today. And so this will be it for today's class regarding inequalities. For next class, we will be covering the topic of graphs